Okay, we're going to be working with the TruPulse 360 laser rangefinder here in RoadEng. Now there's two different ways that we can work with it. The first is through a direct interface in our survey map module. You're able to pair the Bluetooth of the rangefinder over with a Windows 10 enabled tablet that has RoadEng installed on it. Within the survey map module, we can start by just bringing in the points. As you'll see here, we start with the traverse document and then we can import our shot data. The other method that we can use for working with the laser rangefinder is how to import the data that is captured through an Excel file and bring it into the software after the fact. So in the two quick little videos here that follow, you can check out method 1, that's importing directly into a survey map module, or a little bit later here in the video, the second one, which is working with the laser rangefinder data that's being captured and saved into an Excel file. Hope you enjoyed the video, and please reach out to Softtree support if you have any questions. So prior to this demonstration, we've already paired the laser rangefinder with the software in the computer. Instructions for that can be found on Softtree's support knowledge base. To get started, let's open a new traverse document. So the first thing we're going to do here, after we accept these defaults for just the initial coordinate position, we're going to retrieve what we call a screen layout. Screen layouts customize the look of the software and the column arrangements and stuff. So we're going to grab one here that we've pre-set up for the laser rangefinder. You can create your own screen layouts or you can customize the columns of the traverse document yourself. So the first thing we're going to do is take a bunch of radial shots. So let's change this initial shot here over to radial from 4-shot. I'm going to put in a target instrument height here of 1.8. That's my eye height. And we're going to get ready to take our first shot. The device, as I mentioned, it's already paired. We're actually literally out in the field. We have a laptop as well as the laser gun working together, and let's take that first shot. Okay, we've got our first shot here. Just press the Enter key, and that'll save it into the survey map document. Okay, so we're going to use the label column here to give us a bit of what we call like a point code. We're going to label this one as toe. So we're going to go ahead here and just continue shooting some of our radial shots at the toe of the pile, and then transition over to shooting the top of the pile. So we went ahead, continued to survey our pile. We did pause the video here for a second just to skip you having to watch us go around the entire pile. When we changed positions though, however, we did record that position change as a 4-shot, and you'll see that right here in the survey. One of the things that we could have done a little bit better during our survey would be actually to have written our labels in as we took each shot. We did know, however, though, where each type of label, toe and top, started, so we're just doing that after the fact, but for complete accuracy, we would highly recommend doing that in the field. Okay, let's save our survey and take it over to the terrain module. We're going to select File, Open, and go down here to our file type, change that over to a traverse file so we can locate the one that we just saved. Select our file, hit OK. Let's turn on the labels. These are the comments that we recorded in our survey. There they are. It's a little bit better. Now, we don't need all of these lines. So let's select everything. We can do that by hitting Control A. And now let's deselect that actual traverse we recorded by hitting Shift-click on those lines. With just our radial shots selected, we're going to modify their feature property so that they're no longer connected. We can do that over here in the Feature Properties panel by adjusting or deselecting the Connected option and hit Apply. Now we will need to create a polygon feature that's going to represent our toe or the boundary of our pile. So we go up here to New Feature, so we can select Draw with the mouse, and in this case we want to make sure it's a 3D feature that is connected. Now we don't want to worry about the elevation because we're snapping, and I'll show you here in a second. this is going to allow it to pick up the elevations. So we can see the snapping feature selected here in this menu, but we are going to turn off the ability to snap to labels. So now we're just going to snap to the specific feature points. You can see the cursor change when the mouse is right in the right place to snap to that feature point. Now, I think we need another point in here. We missed a point. It looks like we missed a point when we surveyed. And that's probably just because we were lazy. It is a demo video. But for the purposes of this demonstration video, we're just going to add another one in. Now, when we add in a point on a feature line like this, it does interpolate the elevation between the other 2 points. So our Z is roughly going to be, appropriate. We're just guessing a little bit on the XY. Now, we could continue to join the top points to make them a break line, but I don't think we necessarily need that. And let's make our surface first in order to check. One final thing before we do create that surface or that tin model, we need to set our toe to be a tin boundary. And again, we can do that over here in the Feature Properties panel on the side. Now up to our Terrain Modeling tab, press Generate Tin. We can skip the contours and now let's calculate our volume because our surface looks okay. If we had surveyed the original ground or had another previous survey to calculate against, we could calculate the volume between 2 surfaces. But in this case, we can calculate the volume just between our tin boundary or our toe, and we'll use that to represent the original ground and then the rest of the pile survey. There's our volume. It is showing that it's cut, and that's just because we need to switch the original and the final tags. In this case, our tin base boundary should be the original, and our survey pile should be the final. And there it is. We've got our stockpile volume. And that's it for this quick example. Please check out other examples of calculating stockpile volumes between 2 surfaces and other earthwork calculations over on our YouTube page. Thanks for watching.
In this example, I will bring in a survey made with a TruPulse laser, and we'll export the center line from the survey into our survey map module, and we'll use that as a P-line to create a new location design or road design in location module in Softtree's RoadEng. First of all, here's the file. This is the data, and you can see that the first 6 rows aren't being read, and we've got 11 columns with data in them. I have a feeling that the raw TruPulse data had this Z value in column 4, whereas the user who gave me this data had done an extra calculation to offset the elevation to get back to a real elevation. This data is in feet. Anyway, we're going to bring in the real elevation and ignore the surveyed elevation. Other than that, it's probably the same as most TruPulse data files. So let's get started. Now, when I go File Open, inside the Terrain module, I have the option to choose all kinds of options that are already available. The ASCII text import option is pretty close, but it's not quite right. So rather than choose that, what I'll do is I'll go up here and say add a new file format. Pick my TruPulse laser survey, and it's not on the list. Add a new format. I want a format that looks similar to this one, so I select it and then click on Add, and now give it a name. Okay, so we'll call it TruPulse. And okay, it's now in the import options and I can use it. It hasn't been modified yet. Let's do that after we pick the file. So TruPulse laser, here are the options. They're not quite right. If we go and look at the test tab, go through a few records, there's the ones we don't want. Here's the ones that are interesting. It looks like we're getting XYZ, but in fact, if we recall from our file, X is the second column, Y is the third column, and what we're getting here is backwards. X is the third column, Y is the second column. So I'm going to switch that around. Easily done. Back in the structure column or structure tab, I can change the X to be 2 and Y to be 3. There we go. Now there's more. I need to pick a point code. So there's two reasonable choices here. One is column 7, which is category. There are points that are tagged as being P-line points. They are the center line of the survey. Every other point is essentially a side shot or radial shot. And that would be a good choice for point code. The other possibility is to use column 9, which has all these comments in it. Notice that the station number for each P-line point is recorded here. Also, and this will come back to bite us later, notice that station 0 is at line 26, whereas there's another one here, minus 15 is right after it. In other words, these 2 points are out of order. Minus 15 should have come before 0. There's another example of that further down. Okay, so I'm going to use the category column, or column number 7 is my point code, and I'm going to use category column number 9, note, as my label and feature name. Back to the import options. Point code, we want number 7. Feature name 9. Same with comment. That's important. Then we've got these attributes here. Point code, let's make that 7 again. And this one, point number, that's correct. The first column is the point number, 1, 2, 3, counting through the records. So the structure looks good here, and I could read in my data now and I would at least get all the information I need. However, I can use the code tab to actually, oh, one more thing I forgot. We're skipping the first 6 lines. Yeah, okay, so I can use the code tab to filter the data. Let's see what codes we have. There's none, and there's P-line. So none will behave the same as default. They all do it at first. And P-line I'm going to modify. I'm going to connect all the P-line points into a polyline, connect them by code. That just means anything that has the code P-line in it will be made into this polyline. And I'll give it a line type and a color. I could make it a break line. I'm not sure if that's reasonable. I'm going to leave that off. We can do that later. Okay, let's read in the file. Doesn't have a projection defined, that's okay. And there it is. And we look at the file, and there's my connected up P-line feature. And why is it called P00? That's not right. No, I guess it is. The first point in this was called P00. So I want to rename it. I want to call it something else. So I'm going to call it P-line. And there were all those nice comments that had the station number that was recorded in the field. I want to see those. So rather than turn on the comments for all the points, I'm just going to turn on the comments for the selected feature. And the selected feature, I want to see the comments at feature points. Okay, there they are. Let's lock scale and zoom in a bit so you can see those better. Now, if I export this to a TR1 file, these comments will turn up in the file as well. Okay, now remember I said there was an issue at the start. There it is. So the order in which the file, the order in which these points came in the file went 0, minus 15, 50, and clearly it should have gone minus 15, 0, 50. They're out of order. And if I look further down the file, you'll see another example just like that. So station 15 plus 35 comes before 16 plus 22, comes before 16 plus 92, and 79. Okay, so these points are out of order. Often happens, they're labeled correctly, but they're in the wrong order in the file. Easily fixed. I just break them, explode. Now I could have brought them in as points, and then I wouldn't have to do this. If I had brought them in a point as individual point features instead of a polyline, it would look like this. We'd have a bunch of points called, they would have all been named after their name here, and then we would have had to select them and join them together. But I can easily do that now because they're already selected. So let's join them back together, explode and join. And what happens is they come back in a better order. And that same reversal down here has disappeared. It's fixed. Can't see it anymore. Okay, well now I'm ready to export to my TR1 file because not only do I want to see this in the background of my location design, which I would get if I simply use this terrain file, but I also want to have P-line references. And to do that, I do File Save As. Now, before I actually export this, let's go back to the beginning. Turns out the survey module doesn't allow you to have a start station less than 0. So just to head that off right now, I'm going to break the feature here, break at current point. I've now got two features, the first one and the second one, and the second feature starts at station 0. That's the one I'm going to export. Okay. It's the selected feature, so it gets exported when I choose File Save As and TR1. So I've already got a couple in here. Let's save over that one. I don't have a surface, so I can't calculate side shots. I don't need them anyway. I'm going to build a surface in a minute, and we're ready to go. So let's go and open that. Back to the survey map module. Here's the P-line file I just created, and you can see it's got all those comments in it. It starts at station 0 and continues on. And it's got more columns than I need, so I could change that. I could remove some columns here, like side shot, ground type, creek, etc. The other thing I could do is I could open a screen layout, because screen layouts contain all that information. The one you get by default is called normal. That's what we were just looking at. And I saved one in here called TruPulse. In my TruPulse, I added a couple of important columns. Let me show you them. The first column I added is total slope distance. It turns out that was what the surveyor was recording in his station numbering. And then I put in a thing called field reference. Field reference allows me to display one of three items here and to put in station equations. So I'm going to use the total slope distance for my field reference, and when we start out, they're identically the same. Total slope distance is identically the same as field reference, as you would expect. Now the comments, these are the things that are felt penned on ribbons in the field. They look good here. Here's a problem. So the station 630 in the field is actually accumulated slope distance 645 in my traverse. And that error just continues all the way up. So you can see this is too small, so is this one. So that implies to me that I need to put in a station equation. So let's do that. Station equations were designed for this when you have an addition error in the field. I'm not exactly sure how this happened, but I can fix it so that my field reference at least reports the same number as the note that's in the field. Here's how you do it. Traverse options. There's another place to get it, but this is the simplest one. Station equation, add. It's set to total SD already because I set up my reference field to display that. And I want 645 to be, well, I can't see it now. I think it's supposed to be 630. Let's just do that. So 645 is supposed to be 630. There we go. 645 here is 630 there. And now, after I recalculate, 630 here is the same. So that's the accumulated horizontal distance. That's the station equation adjusted field reference. It's less, and it matches better with the one that's in the field. It's not identical, but it's close. Yeah, so if I wanted to get it just right, I could modify that station equation. What does it need? Another meter off, or feet? Another foot off? That'll be close anyway. Okay, and as you go through the notes, you'll see that it gets out of whack later. Again, there's another issue, and I could add another station equation to fix that. But that's basically the idea. Save it. Let's go back to the terrain. Build a surface. Okay, let's use 20-foot contours, and I'm not going to bother labeling them because I don't know what scale I'm at. And that looks fine. Okay, so there's my surface. There's probably more I could do to make this surface better, putting in brake lines, for example. There's all those point codes, so I bet you there's some point codes along here that would give me a brake line that would get rid of that weird triangle. Forget that for the moment. Let's switch over to the location module and create a new location design. Oh, forgot to save it. Let's just go back to terrain again. Save it. Haven't saved it yet once. Okay, save over top of that one. And once again, back to location, new. I still need the terrain. My P-line traverse has no side shots, it has no surface, but it can be used for a reference. And now I have a road design. There are some sharp corners here, but not too many. That's good. So over a mile long. And you can see we're kind of missing the first piece. That's okay, we can add it if we want. The station for the start by default is 0. If I add a piece of segment at the beginning there, it comes in as a minus station number. And everything else looks okay. Now, what about those reference values. Can I display my field reference in the location design? The answer is yes. So first of all, those comments we can see in the background are from the terrain, but I can display those reference values all over the software. I can display them in the plan window labels. There they are, field reference P-line. So if I turn that on, made them a little bigger, and maybe gave them a little offset. There they are. And they should be the same as the ones below. Not identical, but because of our station equations, they're close. Let's just zoom out and lock scale and zoom in a bit. Whoops. What did I just do? Lock scale and zoom in a bit. There we go. So 717, 717. They do line up. That's good. And those references, unlike the labels in the plan window, or the terrain window, sorry, can be displayed elsewhere. They can also be displayed in the section window in the fields below. So these are all the fields I'm displaying underneath the section window. I can add to that my field reference if I want. And similarly, the data window can display the field reference. So yeah, so we're looking at station 0, field reference 0, and as I move through the alignment, you can see that number in the section window. And I could display it in the data window if I wanted to. You get the idea. Right, that's the end of this example. One more quick thing. Back in terrain, I've modified my import options. Module setup, import. There's my new import format. If I wanted to pass this on to somebody else, I could do a save as and put it in a little IOP file. Then I could email that or whatever. And if you want to be really tricky, you can delete most of these before you do your save as. Just make sure you cancel when you leave. And those formats, you can't delete the first two, will go into the file, and then you can use the merge operation to read the file in. I'm in the wrong folder, but you can read IOP files. So another person could get that import format and use it. Thank you.